You know, for the past year or so, we've all been focused on teaching AI how to talk. But that was just the beginning. Right now, we're teaching it how to do. We are on the cusp of a huge shift, moving away from AI that just gives you information to AI that actually takes action on your behalf. This, my friends, is the agent tech revolution, and trust me, it's about to change everything. Let's break down how it all works.
And this right here, this perfectly sums up the difference. A chatbot on the left will tell you how to book a flight. It gives you links, steps, instructions. But an AI agent on the right, it just does it. It interacts with the airline system, books the ticket, and comes back with your confirmation number. It's literally the difference between a helpful librarian who points you to the right aisle and a personal assistant who just goes and gets the book for you.
And let's be clear, this isn't some small incremental upgrade. This is a fundamental shift in how we think about and interact with AI. We're going from a world where we ask AI for answers to a world where we give it a goal and it figures out all the messy steps in between to make it happen. It's like instead of asking for advice, you just hand over your to-do list and it actually gets crossed off. Wild, right?
Okay, so how on earth do these things work? Well, the first step is a mental one. We got to stop thinking of the large language model, the LLM, as the whole shebang. Instead, think of it as just the CPU. It's the brain for sure, but it's only one part of a much bigger system, what we call a cognitive architecture. So let's build one of those, piece by piece.
First up, you've got the brain. This is the LLM, but we give it a very specific job description, a persona. We literally tell it, you are a senior data analyst, you are critical, precise, and you double-check everything. And this isn't just flavor text, it totally changes how the model thinks and acts. It primes it to be hyper-focused on the job at hand.
Next, you need memory. A regular chatbot has the memory of a goldfish. It forgets everything after your conversation. An agent can't work like that. It needs short-term memory to keep track of what it's doing right now, and it needs long-term memory, often something like a vector database, which lets it recall past successes, failures, and important bits of knowledge, just like us.
Okay, so how does an agent actually plan its attack? Well, for simple stuff, it uses what's called a chain of thought, just a simple A to B to C plan. But for really complex problems, it uses a tree of thoughts. It's more like a chess grandmaster. It looks at multiple possible moves, thinks a few steps ahead, and if a path looks like a dead end, no problem. It just backtracks and tries another one.
And now for maybe the most critical piece of the puzzle, the tools. These are its hands, the actions it can actually take. But, and this is so important for safety, the LLM doesn't actually run the code. It doesn't flip the switches. It just decides which tool to use, like search the web or calculate mortgage. It's the brilliant strategist who gives the order, but a completely separate, totally predictable system is the one that actually carries it out. That separation is key.
All right, so we've got the brain, the memory, a way to plan, and the hands to act. How do we wire it all together? It all comes down to a really elegant engine called the React framework. And at its heart is a super simple but powerful loop. Think, then act, then observe.
I love this. It's so simple, but it's what makes agents work. The loop goes like this. First, the agent has a thought about what to do next. Then it picks an action by choosing one of its tools. The system runs the tool and gives back an observation, the raw result. Finally, the agent takes that result and uses it to plan its next thought. And this cycle is what keeps the agent grounded in reality. It can't just make stuff up because it has to constantly check its work against real results from its tools.
Okay, enough theory. Let's see this thing in action, right? We're going to peek inside an agent's mind as it solves a problem. And the question is simple. How much bigger is Earth than Mars?
Okay, turn one. The agent thinks, to figure out how much bigger Earth is, I probably need the mass of Earth first. Makes sense. So its action is to call a tool to get the planet's mass. The system does its thing and spits back an observation, the actual mass of Earth. Boom. Piece one of the puzzle is in place. Now the loop starts over. The agent looks at what it has and thinks, great, got Earth. Now I need Mars. So its next action is to call the same tool, just with Mars this time. And bam, the observation comes back with the mass of Mars. 2 pieces down. All right, final turn. The agent's thought process is basically, okay, I've got both numbers I need, time to do the math. So it calls a different tool, the calculate ratio tool, and feeds it the 2 masses it just found. The system runs the numbers, and the observation comes back, the ratio.
And just like that, there's our answer. The agent can now confidently say that Earth is about 9.35 times more massive than Mars. See how it broke that big question down into tiny, verifiable steps? That's the magic of the React loop.
So that was a pretty straightforward example. But what happens when the problems get really, really messy? I mean, you can't just give one agent 1,000 different tools, right? That's like asking one person to be a brain surgeon, a rocket scientist, and a Michelin star chef. It's just not going to work. The solution? You build a team.
And honestly, the best way to think about these multi-agent systems is like a well-run company. First, you've got the router, who's basically the project manager. Their only job is to look at your request and pass it to the right specialist. Then you have your workers, the specialists. You've got your coder agent, your research agent, each with a small, specific toolkit for their one job. And then, before anything comes back to you, it goes through the critic agent. This is your quality control. They double-check the work to make sure it's accurate. This setup makes the whole system way more reliable.
Okay, we've gone through the blueprint. We've seen the engine in action. Now, it's your turn. We're flipping the script, and you're going to be the architect.
So here's the thought experiment. Your task is to design a stock trader agent. Forget about the code for a second. Just think about the big picture. What components does it need to work well and, more importantly, to work safely?
Let's break it down. First, tools. What are the absolute must-have tools? Maybe something to get a real-time price, another to scan financial news? What else? Second, memory. How would it use memory to keep track of a portfolio? Is that short-term for the day or long-term for performance over years? And here's the big one. Where in that think, act, observe loop do you build in a safety check? At what point do you force the agent to stop and ask a human, "Are you sure you want me to do this?"
And that question about safety and human oversight, that's really the heart of the matter, isn't it? The tech to build AI that can do things in the real world is here. It's not science fiction anymore. So the question we have to ask ourselves is no longer, what can AI do? The real question is, when AI can do anything, what will we have the courage and the wisdom to build?